selection grade lecturer in GPT Tumkur. So today I will be taking applied mathematics 1. So in that today I will be taking the chapter analytical geometry or coordinate geometry. So today we are going to discuss about in analytical geometry there are two chapters. One is basic concepts of analytical geometry and other one is straight lines. So in that first today I will take up the first chapter, that is basic concepts. Basic concepts of analytical geometry. So in this chapter, okay, in exam you are going to get three questions, total 3 questions. In that one is a 2-mark question and 2 questions are from 5 marks questions. So total you will get 12 marks in this chapter for your exam. So one 2-mark question and 2 5-mark questions we are going to get in this chapter from basic concepts. So in basic concepts, basically we are going to discuss about 2 equations. One is a distance formula and other one is a section formula. So before going to that, you should know about coordinates. That means you are going to represent a point in a plane by 2 coordinates, that is x and y coordinates. Coordinates. For that, first I am going to divide this plane into 4 quadrants by considering 2 axes. So one is x axis, that is represented as x dash, and other one is y axis, that is represented as y and y dash. So these 2 axes will intersect at a point called O, and this point is called origin, okay, in this plane. So in this origin you are going to represent coordinates as 0, 0. That means both x and y coordinates are 0 and 0 in this point. So from this point you are going to measure the coordinates. From point O towards x, x coordinate is taken as positive, and towards x dash it is taken as negative. Similarly in y axis, from point O, that is from origin, we are going to measure y coordinate towards y as positive and towards y dash as negative. And suppose you are going to represent a point P x comma y, say point P x comma y in this plane. So in that x represents the x coordinate of that point and y represents the y coordinate. That means suppose if you draw one perpendicular from point P to the x axis, suppose it meets at point M, then this distance OM is taken as a x coordinate of this point P, and the distance PM is taken as a y coordinate of point P. So like this we are going to represent the position of a point from 2 coordinates, that is x and y. So in this figure, say OM is equal to x, represents x coordinate, or it is also called as a abscissa. Similarly, the distance PM is equal to y, represents the y coordinate of point P, or it is also called as a ordinate. Y coordinate, or it is also called as ordinate. So like this you are going to represent a point in a plane by using 2 coordinates, that is x and y coordinates. After this, say in this plane, if we consider any point on the x axis, that means on x axis always the y coordinate is 0. On x axis always y coordinate is 0. Similarly on y axis always x coordinate x coordinate is taken as 0. So, that means if you consider any point on the x axis, on x axis always y coordinate is 0. Similarly, on y axis, that means if you consider any point on the y axis, then always x coordinate is 0. So, in this plane from these two axes x and y axis, you are going to divide this plane into 4 quadrants. That is one is x, o, y, this is called first quadrant of the plane. Then y, o, x dash is called second quadrant of this plane. Then x dash, o, y dash is taken as a third quadrant. Similarly, y dash, o, x is taken as a fourth quadrant. So, like this we are going to divide this plane into 4 quadrants, that is first, second, third and fourth quadrants. So, in these different quadrants we are going to represent a point by 2 coordinates, that is x and y coordinates. In this suppose if you consider a point in first quadrant, then in first quadrant always both x and y coordinates are positive. That means in first quadrant both x and y is positive. Similarly, in second quadrant, okay, see you are going to measure x from O to x dash, that means this is taken as negative. So, here x coordinate is negative and y coordinate is positive in second quadrant. Similarly, in third quadrant both x and y coordinates are negative, and in fourth quadrant x is positive, y is negative. So, like this we get the sign convention in different quadrants of the coordinates. So, that is in first quadrant both x and y coordinates are positive, in second quadrant x coordinate is negative and y coordinate is positive, in third quadrant both x and y coordinates are negative, and in fourth quadrant x is positive and y is negative. Okay. So, that is about sign convention of points in different quadrants. So, always the coordinates of origin is 0, 0, and on x axis always y coordinate is 0, on y axis always x coordinate is 0. So, that is about coordinates of a point. So, after this you are going to discuss about distance formula in this chapter. So, that is first equation that you are going to derive here, distance formula. Then by using that equation you are going to solve some problems on distance formula. So, first equation is a distance formula. Distance formula. It is used to find the distance between any two coordinate points, distance between 2 points. Okay. Suppose if a x1 y1, a x1 y1 and b x2 y2 are any two coordinate points, then the distance between these 2 points is given by distance between 2 points ab is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So, this equation is called distance formula. This equation we are going to derive here. So, to derive this equation I will consider 2 points, say A and B on plane. So, this is x axis and this is y axis and this one is origin. So, I will consider 2 points, let A x1 y1 and B x2 y2 are any two coordinate points on the plane. So, here we are going to find the distance between these 2 points, that means you have to join these 2 points A B like this. So, then this distance A B can be calculated by using distance formula, that is given by square root of x2 minus x1 whole square plus y2 minus y1 whole square. So, how you will get this formula means that you are going to derive here. For that I will draw 2 perpendiculars from A and B to the x axis. So, draw AM perpendicular to OX and BN perpendicular to OX. Okay. So, draw AM and BN perpendicular to x axis or OX. Also draw AC perpendicular to BN. AC perpendicular to BN. So, in this figure the coordinates of point A is x1, y1. That means that this distance OM is taken as x1, that is the x coordinate of point A, and the distance AM is taken as y1, that is the y coordinate of point A. Similarly, the coordinates of point B is x2, y2. That means that in that the distance ON from origin to the point N is taken as x2, that is the x coordinate of point B, and this distance BN is represented by y coordinate, that is y2. So, like this we are going to represent the coordinates of A and B. So, the coordinate of A is x1, y1 and B is x2, y2. These two coordinates will be given, then you are going to find the distance between these two points. So, from this figure, to derive this equation, I will consider in this figure there is one right angle triangle, that is ACB. ACB is a right angle triangle. So, in this right angle triangle, if you write the Pythagoras relation, that is in a right angle triangle ACB, the Pythagoras relation is AB square. AB square is equal to AC square plus BC square, that is Pythagoras relation. So, in this you are going to represent this AC and BC in terms of coordinates, that is from figure it is clear that this distance AC is numerically equal to MN. Since we are going to these two are the perpendiculars, so AC is numerically equal to MN, and MN can be represented as this distance ON minus OM, that is total distance ON minus OM gives the distance MN. So, from this figure it is clear that this distance ON is represented as x coordinate of second point, that is x2, and OM is represented as x1. So, that means this can be written as x2 minus x1. Similarly, this distance BC can be represented in terms of y coordinates, that is from figure it is clear that BC can be written as BC is equal to BN minus CN. BN minus CN. So, in this CN is numerically equal to AM, that I am going to replace, that is BN minus AM. So, in this this distance BN represents y2 from figure, that is y coordinate of point B, and AM can be represented as y1, therefore y2 minus y1. So, like this you are going to express these two distances AC and BC in terms of coordinates. For that you will get AC is equal to x2 minus x1 and BC is equal to y2 minus y1. So, I will substitute these two in this equation, then we get AB square is equal to AC square. AC means x2 minus x1 whole square plus BC square. BC means that is y2 minus y1 whole square. So, from this you can write a distance AB, therefore, distance between these two points AB is equal to square root of, transferring the square to right hand side, we get square root of x2 minus x1 whole square plus y2 minus y1 whole square. So, this equation is called distance formula. Distance between any two points is given by AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. This equation is called distance formula. That means to find the distance between any two points, you are going to use distance formula, that is given by distance between two points A x1 y1 and B x2 y2 is given by AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So, this equation you can derive by using this figure, it is very simple. So, in this figure there is one right angle triangle ACB, in that if you write the Pythagoras relation, we will get AB square is equal to AC square plus BC square. In this AC can be expressed in terms of x coordinates, that is given by x2 minus x1. Similarly, BC can be expressed in terms of y coordinates, that is y2 minus y1. So, substituting in this equation we get the distance formula, that is AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So, this equation is called distance formula. So, by using this distance formula, you are going to solve some examples on distance formula. So, examples in that first I will consider the first example on distance formula. First one, find the distance between the points, find the distance between the points, distance between the points are A minus 1 comma 1 and B 2 comma 4. So, you have to calculate a distance between these two points by using distance formula. So, here 2 points are given A and B, then the coordinates of point A is taken as x1 y1 and coordinates of point B is taken as x2 y2. So, to find the distance between these 2 points, you are going to use distance formula. Since we know that distance between any 2 points is given by AB is equal to square root of formula, distance formula, AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So, here coordinates are given from these two, the points A and B coordinates are given. Substituting these two coordinates in distance formula, we get the distance between these 2 points, that is given by AB is equal to square root of x2 minus x1. So, here x2 is the x coordinate of second point, that is 2, minus x1 is the x coordinate of first point, that is minus 1. So, here in equation there is one minus, in this coordinate also there is one minus. So, minus of minus becomes plus. So, that is 2 plus 1 whole square, that is x2 minus x1 whole square plus y2 minus y1 whole square. Y2 is 4, that is the y coordinate of second point 4, minus y1 is 1, that is y coordinate of first point 4 minus 1 whole square. So, by simplifying this we get the distance between these 2 points, that is given by, that is equal to square root of 2 plus 1 is 3, 3 square is 9 plus 4 minus 1 is 3. So, 3 square is 9, that becomes square root of 9 plus 9 is 18. So, distance AB is equal to 18 units, or you can express this 18 as a square root of 9 into 2. I will write 18 as 9 into 2. So, 9 is the perfect square, that is 3 square is equal to 9, that you can take out from the square root, then this becomes 3 into square root of 2. So, that means the distance between these 2 points is given by AB is equal to 3 root 2 units. So, like this you can find the distance between any 2 points by using distance formula. So, distance between these 2 points, that is A minus 1 comma 1 and B 2 comma 4 is given by AB is equal to 3 root 2 units. So, like this you are going to find the distance. This is the first example. Similarly, you can solve some more problems on distance formula. Then second one, second problem, if the distance between the points, if the distance between the points, distance between the points A, k comma 8 from origin, if the distance between the point A k comma 8 from origin is 10 units, is 10 units, then find the value of k, then find the value of k, constant k. So, in this problem, distance between 2 points is given. In that one point is A, k, comma 8, that is the coordinates of point A is k, comma 8. In this k is constant, that value is not given, that you have to find out. So, the distance between this point from origin is 10 units, that is given. So, another point you have to take as origin. So, we know the coordinates of origin. Since the coordinates of origin always 0, comma 0, that means suppose this is the origin point O, I will consider origin as point O, and the coordinates of this point is 0, comma 0, and the given point is A. So, the coordinates of point A is k, comma 8, and the distance between these 2 points is given, that is origin to the point OA, the distance is 10 units, that is given. So, you have to find the value of constant k. In this to find the distance between these 2 points, once again you are going to use distance formula, that is distance between these 2 points, say OA, okay, is given, that is equal to 10 units. Distance between these 2 points is 10 units. So, to find the distance between these 2 points, here you are going to use distance formula, that is square root of distance between these 2 points is given by square root of x2 minus x1 whole square. Say in this O is the first point origin, the coordinates of this point is taken as x1, y1. Similarly, A is the second point, the coordinates of second point A is taken as x2, y2. Then according to distance formula, distance between these 2 points OA is equal to square root of x2 minus x1 whole square. So, x2 means here x2 is equal to k minus x1 is 0 whole square plus y2 minus y1. So, y2 is 8 here and y1 is 0. So, y8 minus 0 whole square is equal to 10 units, that is given. Distance AB is equal to 10 units. So, by simplifying this equation, we get the value of constant k, that is this can be written as square root of k minus 0 is k square. So, that is k square plus 8 minus 0 is 8, 8 square is 64 is equal to 10. So, to calculate the value of k, that is under the square root. So, first you have to remove the square root by squaring on both sides. So, squaring on both sides, we get k square plus 64, square and square root gets cancels in left hand side, k square plus 64 is equal to 10 square, or you can write this as k square plus 64 is equal to 10 square is 100, 10 square is equal to 100, therefore, k square becomes equal to 100 minus 64, that is equal to 36. So, here k square is equal to 36, therefore, value of k is equal to square root of 36. Square root of 36 means you can take a plus or minus 6, since 6 square is 36. Therefore, the value of k is equal to plus or minus 6. So, like this you can calculate the value of k here. Okay, since the distance between 2 points is given, in this one point is a k, comma 0 and other second point is origin, then the coordinates of origin is 0, comma 0. So, by considering distance between these 2 points OA is equal to 10 units. So, to find the distance OA, you are going to use distance formula here, that is square root of x2 minus x1 whole square plus y2 minus y1 whole square. So, substituting the coordinates in this formula and simplifying, we get the value of k here, that is k is equal to plus or minus 6, that means you can take plus 6 or minus 6, this k value. So, like this you can find the value of k in this problem. So, after this we are going to discuss some more problems on distance formula. Next problem, third one. Show that the points minus 2 comma 5, 3 comma minus 4 and 7 comma 10. Show that the points are minus 2 comma 5, 3 comma minus 4 and 7 comma 10 form a right angled isosceles triangle. Form a right angled isosceles triangle. Forms a right angled isosceles triangle. So that you have to prove here. Here the coordinate points, 3 points are given, that is minus 2 comma 5, 3 comma minus 4 and 7 comma 10. So, I have to show these 3 points forms a right angled isosceles triangle. So, here right angle triangle means in terms of distances you have to prove Pythagoras relation. Pythagoras relation means suppose if ABC is a triangle like this, ABC. So, in this Pythagoras relation means if AC square is equal to AB square plus BC square, then that shows that this triangle is a right angle triangle, and for isosceles triangle you have to prove that any two sides of the triangle is equal. So, if both the conditions are satisfied, then you can it shows that this triangle is a right angled isosceles triangle. So, for that first I will consider the given points as A, B, C. Let point A, the coordinate of point A is minus 2 comma 5, point B 3 comma minus 4 and C 7 comma 10 are the given points. So, first you have to find the distance, that means the 3 sides of the triangle by using distance formula. So, for that distance AB is given by using distance formula. AB is equal to square root of x2 minus x1 whole square. So, here x2 means the x coordinate of second point B, that is 3, minus x1 is minus 2. So, here there is one minus, minus of minus becomes plus 2 whole square, that is x2 minus x1 whole square, plus y2 minus y1, y2 is minus 4, okay, minus y1 is 5 whole square, y2 minus y1 whole square. Then the distance AB is equal to square root of 3 plus 2 is 5, 5 square is 25, plus minus 4 minus 5 becomes minus 9. So, minus 9 whole square is 81 plus 81. So, that is distance AB is equal to square root of 25 plus 81 is 106. That gives a distance between these 2 points AB, that is equal to square root of 106. So, similarly, we are going to calculate a distance between B and C, that is BC. BC is equal to square root of, so B is the first point, C is the second point. Distance between these 2 points is given by BC is equal to square root of x2 minus x1 whole square. x2 means the x coordinate of second point C 7, minus x1 is the x coordinate of first point B, that is 3. So, 7 minus 3 whole square plus y2 minus y1 whole square. y2 is the y coordinate of second point C, that is 10, minus y1 is the y coordinate of first point B, that is minus 4. So, minus of minus becomes plus 4 here, 10 minus 4 whole square. So, by simplifying this one, you get square root of 7 minus 3 is 4, 4 square is 16, plus 10 plus 4 is 14. So, 14 square is 196, 14 square. So, adding these two, we get distance BC is equal to square root of 16 plus 196 means that is 212 units. That is distance between B and C. Similarly, we are going to calculate another side of the triangle, that is AC, by using distance formula. So, AC is given by AC is equal to square root of, here A is the first point and C is the second point. So, square root of x2 minus x1 whole square means x2 is the x coordinate of second point C, that is 7, minus x1 is the x coordinate of first point A, that is minus 2. So, minus of minus becomes plus 2 here, 7 plus 2 whole square, x2 minus x1 whole square, plus y2 minus y1 whole square. Y2 is the y coordinate of second point C, that is 10, minus y1 is the y coordinate of first point A, that is 5. So, 10 minus 5 whole square. So, simplifying this one, we will get a square root of 7 plus 2 is 9, 9 square is 81, plus 10 minus 5 is 5, 5 square is 25. So, square root of 81 plus 25, we get a square root of 106. So, like this we are going to calculate 3 sides of the triangle. Then by observation it is clear that here 2 sides are equal, that is AC, AB and AC is equal to 106. 2 sides are equal. From by observation, AB is equal to AC is equal to square root of 106. So, in any triangle, if 2 sides are equal, then that is called isosceles triangle. In addition to that, you have to prove that this is a right angle triangle also. So, to prove that one, you have to show that this satisfies the Pythagoras relation. That is, Pythagoras relation means AB square plus AC square is equal to BC square here. From observation, AB square plus AC square is equal to BC square. That is, AB square means AB is equal to square root of 106. So, square of that is 106 plus AC square is square root of 106 whole square is 106 is equal to BC square is BC is the square root of 212, square of that is 212. That means 106 plus 106 is 212 is equal to 212. So, here both the conditions are proved, that is, one is Pythagoras relation, AB square plus AC square is equal to BC square, and 2 sides are also equal. Then that shows that this triangle ABC is a right angled isosceles triangle. Okay. So, like this you can prove the given points as forms the right angled isosceles triangle. So, it is to prove this triangle as a right angled isosceles triangle, you have to show these 2 conditions. One is the Pythagoras relation, that is AB square plus AC square is equal to BC square, and other condition is 2 sides are equal. So, that shows that this triangle is a right angled isosceles triangle. So, after this next problem, fourth one, find the nature of the triangle formed by the points. Nature of the triangle formed by the points A 2, 4, B 2, 6 and C 2 plus root 3, 5. So, find the nature of the triangle formed by these 3 points. So, here 3 points are given A, B, C. The coordinates of point A is 2, 4. In this 2 is the x coordinate and 4 is the y coordinate, and coordinate of point B is 2, 6. Here 2 is the x coordinate of point B and 6 is the y coordinate, and the coordinates of point C is 2 plus root 3, 5. So, in this 2 plus root 3, this whole together is x coordinate of point C and 5 is the y coordinate. So, here you have to find the nature of the triangle formed by these 3 points. That means, if these 3 points A, B, C forms a triangle like this, forms a triangle ABC, then what is the nature of the triangle ABC, that you have to identify. So, for that first you have to calculate all sides of the triangle, that is AB, BC and AC by using distance formula here. Okay. So, first I will find the distances between 2 points, that is first side AB of this triangle is given by AB is equal to square root of, by using distance formula, square root of x2 minus x1 whole square. So, here x2 means x coordinate of second point B, that is 2, minus x1 is x coordinate of first point A, that is also 2. So, 2 minus 2 whole square, x2 minus x1 whole square, plus y2 minus y1, y2 is the y coordinate of second point B, that is 6, minus y1 is the y coordinate of first point A, that is 4. So, 6 minus 4 whole square, y2 minus y1 whole square. So, by simplifying this we get square root of 2 minus 2 is 0, 0 square is 0, plus 6 minus 4 is 2, 2 square is 4. So, that is equal to square root of 0 plus 4 is 4, that you can write 2 units, that is the distance AB is equal to 2 units. Then find the distance between B and C, that is BC, by using distance formula. BC is equal to square root of, BC is equal to square root of, here B is the first point and C is the second point. See, the coordinates of first point is taken as x1 y1, x1 y1, and coordinates of second point is taken as x2 y2. So, here by using distance formula, x2 minus x1, x2 is 2 plus root 3 minus x1 is 2 whole square, plus y2 minus y1 whole square, y2 is 5 minus y1 is 6 whole square. So, by simplifying this we get square root of here 2 plus root 3 minus 2 is there, plus 2 minus 2 gets cancels, root 3 whole square. So, root 3 whole square means we get 3 plus 5 minus 6 is minus 1, minus 1 whole square is plus 1 only. So, that is a square root of 3 plus 1, or you can write this as square root of 4, or that is equal to 2 units only, that is BC. And finally, find the distance between A and C, that is AC, by using distance formula. So, AC is equal to square root of A and C is A is the first point and C is the second point. The coordinate of first point is x1 y1 and second point is x2 y2. So, according to distance formula, distance between these 2 points AC is equal to square root of x2 minus x1 whole square, x2 is 2 plus root 3 minus x1 is 2 whole square, plus y2 minus y1 whole square, y2 is 5 minus y1 is 4 whole square. So, by simplifying this we get here plus 2 minus 2 gets cancels, square root of 3 whole square is 3 only, plus 5 minus 1 is 5 minus 4 is 1, 1 square is 1. So, that is a square root of 4, or you can write this as 2 units. So, all sides AB, BC and AC are equal. From observation it shows that AB is equal to BC and that is equal to AC is equal to 2 units. So, in any triangle, if all 3 sides are equal, then what is the nature of the triangle formed? Since in this all sides are equal, then the triangle ABC is called, it is a equilateral triangle. All sides are equal means it is a equilateral triangle. Therefore, ABC is a equilateral triangle. ABC is a equilateral triangle. That is the nature of the triangle formed by these 3 points. So, like this you can find the nature of the triangle if the coordinate points are given. Say if 3 points are given, usually you get to 4 types of triangles. In that, first one is equilateral triangle. If all 3 sides are equal, then that forms a equilateral triangle. If out of 3 sides any 2 sides are equal, then the triangle is called isosceles triangle. If Pythagoras relation is satisfied, that is AB square plus BC square is equal to AC square, then the triangle is called a right angle triangle. Sometimes both the conditions will satisfy, that is if the Pythagoras relation is satisfied and 2 sides are also equal, then the triangle is called right angled isosceles triangle. So, like this there are 4 types of triangles can be formed by using 3 coordinate points. So, that you can identify the nature of the triangle by observation, by calculating the distances here, distance AB, BC and AC. So, this is one type of problem. After this instead of 3 coordinate points sometimes they will give 4 coordinate points. So, if 4 coordinate points are given, then that forms a quadrilateral. So, in quadrilateral also there are 4 combinations, in that one is a parallelogram, second one is a rectangle, third one is a square and one more is a rhombus. So, what is the differences between these two? This is say to, if the points forms a parallelogram means in parallelogram what condition should be satisfied is in parallelogram opposite sides are equal, okay, opposite sides are equal and the diagonals are not equal in case of parallelogram. Suppose if opposite sides are equal and diagonals are also equal, then that forms a rectangle, okay. So, that is the difference between parallelogram and rectangle. Similarly, square and rhombus also, in square all 4 sides are equal and diagonals are also equal, square means, but in case of rhombus all 4 sides are equal but diagonals are not equal. So, like that I will consider 1 or 2 examples here, 4 coordinate points. So, next problem, show that the points 3, 1, 2, 2, 0, 1 and 1, 0 be the vertices of a parallelogram. Vertices of a parallelogram when taken in order. So, here what you have to prove is these 4 coordinate points forms a parallelogram when taken in order. So, that means order means I will consider let A 3, 1, B 2, 2, C 0, 1 and D 1, 0 be the given coordinate points A, B, C, D taken in order. So, then you have to prove that these points forms the vertices of parallelogram. So, to prove this forms a parallelogram means the condition for parallelogram is in case of parallelogram opposite sides are equal and diagonals are not equal, that you have to prove here. See, parallelogram means you will get like this. Suppose if consider this is a parallelogram. So, A, B, C, D is a parallelogram if opposite sides are equal, opposite sides are AB and DC should be equal and AD, BC should be equal, opposite sides are equal, and then diagonals means if you join AC, this is one diagonal and BD, this is another diagonal. So, these diagonals are not equal in case of parallelogram. If diagonals are also equal, then that forms a rectangle here. So, here you have to prove that these points forms a parallelogram means opposite sides are equal and diagonals are not equal, that you have to prove. So, for that first I will calculate the distances here. So, one is AB, side AB is equal to, by using distance formula, AB is equal to square root of x2 minus x1 whole square. Here x2 is 2 minus x1 is 3 whole square plus y2 minus y1, that is 2 minus 1 whole square. So, by simplifying we get square root of 2 minus 3 is minus 1, whole square is plus 1 plus 2 minus 1 is 1, 1 square is 1. So, that is equal to square root of 2. that is side AB. Then BC is equal to square root of B and C, distance between these 2 points is given by square root of x2 minus x1, that is 0 minus 2 whole square, plus y2 minus y1, that is 1 minus 2 whole square. So that gives square root of 2 square is 4, plus 1 minus 1 is minus 1, whole square is plus 1, that is equal to square root of 5, that is side BC. Then CD is equal to square root of x2 C and D, distance between these 2 points. So here C is the first point, D is the second point. So x2 minus x1 means 1 minus 0 whole square, plus y2 minus y1, that is 0 minus 1 whole square. So by simplifying this, we get square root of 1 minus 0 is 1, 1 square is 1, plus 0 minus 1 is minus 1, square is plus 1. So 1 plus 1 is square root of 2, that is distance CD. And AB, last side, AD is given by square root of, so A is the first point and D is the second point, distance between these 2 points AD is equal to x2 minus x1, that is 1 minus 3 whole square, plus y2 minus y1, 0 minus 1 whole square. So that gives square root of 1 minus 3 is minus 2, whole square is plus 4, plus 0 minus 1 is minus 1, whole square is plus 1, that we get the square root of 5. So here by observation it is clear that opposite sides AB and CD, are equal, that is equal to root 2, and AD BC are also equal, AD BC is equal to square root of 5. So here opposite sides are equal. If opposite sides are equal, then that may form rectangle, or parallelogram. So particularly here I have to prove that these points forms a parallelogram, means in parallelogram diagonals are not equal, that you have to show here. So first I will calculate the diagonals here. So in this we will get to 2 diagonals, one is AC and other one is BD. So first I will calculate diagonal AC, that is distance between the points A and C by using distance formula, that is given by AC is equal to, A is the first point and C is the second point here. So distance between these 2 points AC is equal to square root of x2 minus x1, that is 0 minus 3 whole square, plus y2 minus y1, y2 is 1 minus 1 whole square. So that will get the square root of minus 3 whole square is 9, plus 1 minus 1 is 0. So square root of 9 is 3, that is diagonal AC. And I will calculate another diagonal BD, that is given by BD, distance between the points B and D. B is the first point and D is the second point here. So that is given by BD is equal to square root of x2 minus x1, 1 minus 2 whole square, plus y2 minus y1, 0 minus 2 whole square. So that is equal to square root of 1 minus 2 is minus 1, whole square is plus 1, 0 minus 2 is minus 2, whole square is plus 4. So that we will get square root of 5. So from observation it is clear that opposite sides AB is equal to CD, that is equal to square root of 2, and BC is equal to AD, that is equal to square root of 5. Then the diagonals AC and BD is not equal, AC is not equal to BD. So that shows that these points forms a parallelogram. Therefore ABCD is a parallelogram. ABCD is a parallelogram. So like this you can prove that these points are the vertices of a parallelogram. So for that you should know the conditions here. For parallelogram opposite sides are equal and diagonals are not equal. Then if the diagonals are also equal, then that forms a rectangle. Similarly, if four sides are if 4 sides are equal, then that forms a square or a rhombus. So, in case of square, all 4 sides are equal and rectangles and the diagonals are also equal. In case of rhombus, 4 sides are equal and diagonals are not equal. So, I will consider one more example on 4 points. Show that the points 0, 2, 1, 0, 3, 1 and 2, 3 are the vertices of a square when taken in order. So, for square you have to prove that all 4 sides are equal and diagonals are also equal. Square means suppose this is a square. So, A, B, C, D is a square. Then here all 4 sides are equal in case of square, and diagonals, that is AC, BD, diagonals are also equal. That you have to prove here. So, for that I will consider the given points as A, B, C, D. So, let A 0, 2, B 1, 0, C 3, 1 and D 2, 3 are the given points. Then distance AB is equal to, by using distance formula, square root of x2 minus x1 whole square 1 minus 0 whole square plus y2 minus y1 0 minus 2 whole square. That we will get square root of 1 square is 1 plus minus 2 square is 4, that is square root of 5. Then second side BC is equal to square root of BC x2 minus x1 3 minus 1 whole square plus y2 minus y1, that is 1 minus 0 whole square. That will get the square root of 3 minus 1 is 2, square is 4 plus 1 square is 1, that is a square root of 5. Then third side CD is equal to square root of CD x2 minus x1 2 minus 3 whole square plus y2 minus y1, that is 3 minus 1 whole square. So, square root of 2 minus 3 is minus 1, square is 1 plus 3 minus 1 is 2, 2 square is 4, that is equal to square root of 5. And last side DA is equal to square root of, D is the first point and A is the second point here. So, 0 minus 2 whole square plus 2 minus 3 whole square, that is square root of minus 2 square is 4 plus 2 minus 3 is minus 1 whole square is plus 1, that is square root of 5. So, here by observation it is clear that all 4 sides are equal, AB, BC, CD and DA is equal to root 5. In addition to this, you have to prove that diagonals are also equal here. So, diagonals means that is AC and BD. We will calculate AC is equal to square root of A and C. So, A is the first point and C is the second point, x2 minus x1 3 minus 0 whole square plus y2 minus y1, that is 1 minus 2 whole square. That will get a square root of 3 square is 9 plus 1 square is 1, that is root 10. Similarly, another diagonal BD is equal to square root of, B is the first point and D is the second point, 2 minus 1 whole square plus 3 minus 0 whole square, that is square root of 2 minus 1 is 1 square is 1 plus 3 square is 9, you get square root of 10. So, from observation here it is clear that all sides are equal and diagonals are also equal, that is AB is equal to BC is equal to CD is equal to DA, that is equal to root 5, all sides are equal, and the diagonals AC is equal to BD, that is square root of 10. So, that shows that these points are the vertices of a square, therefore, thus ABCD is a square. ABCD is a square. Suppose in this case, if diagonals are not equal, then that forms a rhombus. Okay. So, like this you can prove the given points are the vertices of a parallelogram or rectangle, square or rhombus by using this distance formula. So, these are the different types of problems on distance formula. So, today we have discussed that we have derived first distance formula, that is the distance between any two points A x1 y1 b x2 y2 is given by square root AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square, and by using that distance formula I have discussed some problems here. Okay. So, that is about problems on distance formula. So, in next class we are going to discuss about a second equation in basic concepts of analytical geometry. So, that is called a section formula. Section formula. So, that I will take up in the next class, section formula and problems on that. That also you are going to derive here, section formula, then you are going to solve some problems on section formula. So, that I will continue in next class. Thank you.